So in today's video, we'll be looking at isomerism of alkanes. So one of the most peculiar and common type of isomerism in alkane is structural isomerism. So we have different types and forms of isomerism, but today's class we'll be looking at structural isomerism. Now these are alkanes from one carbon to seven carbon. First, one carbon methane, two carbon ethane, three carbon propane, four carbon butane, pentane, ethane, and heptane. So the name is given to it according to number of carbon atom it has. Met is one, earth is two. I hope you guys understand. So now, you are likely to be asked questions on, maybe they will ask you that how many isomeric how many isomeric compound does maybe butane or pentane or ethane, how many isomeric compound do they have? Okay, that means in how many forms can they be drawn? I hope I'm clear. So isomerism is basically a structural isomerism is basically molecules or compounds that have the same molecular formula but different structural formula. That means they can be drawn in probably different ways. Some can be done in two different ways, three different ways, four different ways, up to 1,000 different ways, depending on the number of how big the molecule is. Now, we have methane here, we have ethane, we have propane. So, to be sincere, isomerism starts from butane actually. That's when you can start having iso. That's when you can start having isomeric compound. But for your methane, ethane, and propane, you are less likely to have any isomeric compound because they are very small. For example, now let's say this is ethane C. Okay, so I have another issue. Then I have another issue. So sorry, I'm going to draw ethane. So I have another issue. I have another issue. So as you can see, I have 6H and 2 hydrogen. So if I'm to draw another form of this compound, it's going to be very, very difficult. There's no way I want to do it. There is no way I want to do it to draw another form of this exact compound. But for our, let's take butane for example. We have C, 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 and C. So I don't know, the hydrogen are not really necessary. So, but let me just put it. So for our butane, we have, don't mind the way I'm drawing it. So for our butane, okay. So for our butane now, there are other ways I can actually draw this. Instead of drawing it as a straight line, this is one form. I can also draw it this way, maybe like C, C, C. Then I put one here. I put another C here. So I have, so this is another form of butane here. So I can see this is the second form. So I can easily say butane has two forms. There is no other way I can draw this. If I'm to put this carbon here, it's going to form this. If I'm to put it here, so it's going to form the same thing. So we can only draw butane in two forms. Now for pentane too, we draw it that way, we get the number of isomerism. But for exam sake, maybe you are giving, most especially MCQ exams you are asked to, where you are given options you get, or you don't have much time and you have to find the isomerism of this compound, there's a formula you can use to get isomerism of most alkanes you get, and I'm going to be explaining the formula in this video. So the formula is a very, very simple formula. This is the formula. The formula is 2 raised to power n minus 4 plus 1. So this is the formula we'll be using to get the number of isomerism of any compound without drawing this the diagram of the compound, the structural formula of the compound, because it's going to take much of our time. So we just apply the formula and we get the isomerism of the compound. Now for our methane, number of carbon molecule will be our n. So 2n minus 4, that will be 2 raised to power, for our methane is going to be 2 raised to power 1 minus 4. So again, 1 minus 4 plus 1. So if we are to do this now, if we are to do this, okay, so 1, sorry, is 1 minus 4 please. So 1 minus 4 automatically is minus 3. So that's going to give us anything minus. That means we don't have, whenever we are getting a negative answer, we simply say we don't have isomerism for that compound. 1 minus 4 cannot give us that. So same thing applies to your ethane too. 2 minus 4, we are going to have something raised to power negative. So we say we don't have an isomeric compound for these two. So for our propane too, 3 minus 4 plus 1, we say we don't have an isomeric because we get it. We have 2 raised to power minus 1 here. We say we don't have an isomeric compound for propane. Now for our butane, 2 raised to power 4 minus 4 plus 1. What's 4 minus 4? 4 minus 4 is 0. So 2 raised to power 0. Anything raised to power 0 is 1. Then we have 1 plus 1. Then we have 2. So we have answer will be 2. So if they ask you how many isomeric compound do we have for butane, you say 2. Now for pentane now, that will be 2 raised to power 5 minus 4 plus 1. So 5 minus 4 is 1, right? 2 raised to power 1, 2. 2 plus 1, 3. So pentane has 3 isomeric compound. So we can draw it in 3 different ways. I hope I'm clear. So I would like you guys to pause this video and try for hexane and heptane very, very quickly. So I hope you've paused the video and tried it yourself. So let me solve it for you guys. So for hexane, we have 2 raised to power 6 minus 4. So what's 6 minus 4? We have 2. 6 okay, let me write it out for you guys. 6 minus 4 plus 1. So 6 minus 4 is 2. 2 raised to power 2. That's 2 times 2. That's 4. 4 plus 1, we have 5. So we can draw hexane in 5 different ways. Now, heptane here, that will be 2 raised to power 7 minus 2. That will be 5. Sorry. Okay. So heptane here, we have 7 minus 2. That will be 5 plus 1. So starting from here, so 7 minus 4 here. 7 minus 4 here, we have 3. So plus 1. So 7 minus 4 is that will be 2 raised to power 3 plus 1, right? So 2 raised to power 2 times 2 for 4 times 2, that's 8 plus 1. We have 9. I hope I'm clear. So this is 6 minus 4 for those of you that are confused. So 6 minus 4, we have 2. 2 times 2, 4 plus 1, we have 5. So here to 7 minus 4, we have 3. 2 raised to power 3 plus 1, we have 9. So this is how we get the isomerism of the first 7 um compounds of alkane. So one thing you should know that this formula does not really work for higher uh higher carbon atoms starting with 8 and above. It starts to get disorganized. But one thing you should know that for your exams, you are less likely to be asked compound that are above 7. Even for those of you taking UTME, it is stated in your UTME syllabus that they are going to stop asking you questions from hexane. So knowing up to heptane is an advantage. So in your UTME syllabus, it is written here that they're going to stop asking you from hexane. And in most of your exams, you are not going to be asked above heptane. Knowing up to heptane alone is kind of what your time you're supposed to use to draw about 9 different compounds before you can get the number of isomeric compound available for the alkane you are trying to draw. So I hope I'm clear. So I hope this video has helped you in one way or the other. Make sure you like this video so that YouTube will recommend it to other students. And if you have any question, you can ask in the comment section. Thank you. And don't forget to subscribe to the YouTube channel.